Hello, welcome to Science Chomp. Today we're going to be balancing equations. Now let's just get right into it. I've written a very simple equation here, and we're going to start off with this, and then we're going to get progressively a little bit harder. So first up, I'm actually going to draw it out just so that you know the reasoning behind this balancing of equations. So first up, I've got H2, okay? So that's two hydrogens covalently bonded together like so. And that reacts with O2, which is an oxygen and another oxygen like that. And it forms H2O. So we give it a plus here, and then we give it an arrow. And then we've got to draw an oxygen like this. And it's covalently bonded to hydrogens kind of like that. Now, according to the law of conservation of mass, you have to have equal numbers of atoms before and after the arrow. So before the arrow and after the arrow. So these are the reactants, and this is what we call the product. Okay, so let's get into it. Remember, the one thing I can't change is I can't decide, okay, well, I've only got one here, and I've got two over here, so I'm going to just add another oxygen here. It doesn't work that way. I've got to have the whole molecule added again. So let's take a look at what we mean. First of all, what we've got to do is we've got to draw ourselves a little table, a before and after table. Okay, so this means before the arrow and after the arrow. And what we've got to do is list the atoms. So we've got H and we've got O. Before we've got 2, after we've got 2. That seems okay. What about oxygen? We've got 2 oxygens before, and afterwards we only have 1. Now, like I said, the temptation is to add another oxygen up over here, but it doesn't work that way. I need the whole thing. So I've got 2 here, 1 here. I've got to double this. So I'm going to draw another H2O like this. Okay, so let's see what that gives us. Now we've got the right number of oxygens. Okay, we've got 2 oxygens now. But unfortunately, you've got 1, 2, 3, 4 hydrogens. Like that. So we've got double the number now on this side for hydrogen. Then we have before the arrow. So we've got to change that one before the arrow. Not a problem. We only need 2 more, and conveniently it comes into like so. Okay, so now if you have a look, you've got 4 hydrogens before, 4 hydrogens after. Oxygen you've got 2, and after you've got 2. Everything's balanced. Now, we can't present a balanced equation in this manner, okay? We've actually got to do it a little bit like this, but with numbers. So we do it like so. Let me just write it out in front. So H2 plus O2 gives you H2O. I've got 2 of those, 2 H2Os, so I've put 2. This is what we call a coefficient. This is what we call a subscript. We do not change subscripts here. We only change coefficients. Over here, we have 1, 2 lots of H2, and that's it. That's how it gets balanced, okay? You get the mark for this part. This part's just working out. Like, you don't really get marks for this part, but you can't solve it without doing this. Okay? Let's try another easy one. We've got Zn plus HCl giving you ZnCl2 and H2. So as before, what we've got to do is we've got to do a before and after. So before the arrow, remember these are the reactants, and after the arrow, which are the products. Okay, so before we've got Zn, H, and Cl. We've got one of those, we've got one H, and we've got one Cl. And after, we've got one Zn, we've got two H's and two Cl's, okay? So what we've got to immediately figure out is that we need double the amount of these. Instead of one, we got to have two. So I'm going to change this coefficient to 2, and that changes my hydrogen to 2 and my chlorine to 2 on the before side. And now, as you can see, everything is balanced. Let's look at another one. We've got SiO2 plus HF giving you SiF4 and H2O. So as before, we need a before and after. And remember, the idea is we can change one side and then change the other side and keep going backwards and forwards. But let's just have a go at this, and let's see where it takes us. So we've got Si, we've got O, we've got H, we have F. These are all the different atoms. Si, we've got 1 before. Oxygen, we've got 2 before. H, we've got 1 before. And F, we've got 1 before. Over the other side, we've got 1 silicon. We've got, for oxygen, just the 1. For hydrogen, we've got 2. And for fluorine, we've got 4. Okay? So each time what I'm doing is I'm looking at the subscript. The subscript tells me how many of that particular atom that there is. Okay? Then we get the before and after table, which looks a little bit like this. Now, immediately I can see I need double the number of oxygen over here, double the number of hydrogen over here, and 4 times the number of F over this side. So that's what I'm going to do first of all. I'm going to give it 4HF, okay? So that's going to change that hydrogen to 4 and that fluorine to 4 as well. Now immediately you can see I now need double the number of oxygens and double the number of hydrogens on the product side. So I'm going to put a number 2 because it's double the number up over there. And let's see what that gives us. That gives us how many hydrogens? 2 times 2, this is going to be 4. And 2 times 1, well, this is 2. So you've got 1 and 1, 2 and 2, 4 and 4, 4 and 4. So this is balanced. Nice and easy. Let's look at something a little bit more interesting. Excuse my poor handwriting here. But anyway, we've got Al plus O2 gives you Al2O3. Now, interestingly, we've got 2s and we've got 3s. And what we've got to do is we've got to find out the lowest common multiple of 2 and 3. And what I mean by that is do the times table for 2. So it's 2, 4, 6, 8, and 10. And do the same for 3. So you've got 3, 6, 9, 12, and 15, like so. The lowest common multiple is the lowest number they both have in common when you multiply them out. And that number happens to be 6. Okay? So that's the number that we're going to be gunning for when we're balancing this equation up here. So as before, we've got to do a before and after. Before and after. And we've got to write out our atoms, Al and O. So before we've got 1, after we've got 2. Before we've got 2 oxygens. After we've got 3 oxygens. So as I said before, we're trying to get to the lowest common multiple, and we're going to see where that takes us. So we've got 2 over here. We're going to try and get this whole thing to 6 atoms of oxygen. So how many do we need? Well, we need 3 lots of O2 because 3 times 2 is 6. That gives us 6 over here. And we're going to have to try and do the same for this whole thing. So something times 3 gives you 6. Well, that's going to be 2. Okay? So now 2 times 3 is 6, but also it changes the number of aluminiums. Now I've got 2 times 2 which is 4. Okay, so now the oxygen is balanced. We've got 6 either side, but the aluminium isn't. So we've got to add a coefficient in front of that aluminium to make it 4. So of course, we just need 4 atoms of aluminium over there. Okay, let's try something a little bit more tricky. We've got here H3PO4 plus HCl giving you PCl5 and H2O. Now the main thing is never ever fear. Let's just smash this. All right, you're going to start off the same way that you did with all of the other ones. You need a before and an after table. Okay, so before we've got H's, we've got P's, we've got O's, and we have Cl. In terms of H's, we've got 3 here, 1 over here, that's 4. And afterwards, we've just got the 2. Before for the P, we have 1. Afterwards, we have 1, so that's fine. Oxygen, before we have 4. Afterwards, we just have 1. And then Cl, before we have 1. And afterwards, we have 5. Oh dearie me, this looks complicated, but fear not. What we've got to do is we've got to decide, okay, well, we've got to change this one here, this one, and this one. Okay, since this is the biggest difference, I'm going to go right ahead and change the chlorine one first. So if I've got 5 of them after, of course I need 5 of them before. Okay, so this is going to change that to 5, but it's also going to change the hydrogens. We've now got 5 here and 3 there. 5 plus 3 is 8. Okay, now what we've got to now do is make sure we've got the same number of hydrogens over here. Okay, so if we've got 8 hydrogens here, we've got to have 8 hydrogens over there. And 4 times 2 is going to be 8. Okay, so that part balances out, but it also changes the number of oxygens. Now we've got 4 times 1, and that's 4. And coincidentally, this balances out the entire equation. We've got 8 here, 1, 4, 4, 5, 5. So it's all balanced out. And it's as simple as that. Just be careful, just go backwards and forwards. It doesn't matter if you make a mistake, you can still just scribble it out and start again. Just make sure you make a table, you count the number of atoms before and after, and remember, you only change the coefficient, you never ever change the subscript. Okay, thank you very much for watching. Goodbye.